Hello guys, it's your guy Fiera. Welcome back to the Rocket Series Academy. Today we are going to be generating the M&G code required for VMS Project 13. Let's dive into the project. Looking at the CAM path definition, coordinate system, we are using Mach 1 for the main spindle and Mach 2 for the back spindle. Stock definition, for the facing we are using 0.002. For the clamping, we are using minus, go for the green check. Target, we are using the CAD model. Show target, go for the green check. Okay. Setup, the setup is done as in the previous tutorial. Starting with the main spindle operation. For our first operation, we have facing. Looking at the facing operation. Geometry, we are using Mach 1, show geometry. Our geometry is simply this face. Tool, show tool parameter. We got two extender tools. Firstly, we got an extender tool of angle 60 degree, and equally we got an extender cutting tool of angle 35 degree. So this tool is used for the roughing, used for the surface finish. With this selected, go for the green check. Technology, we are using front with a roughing pass, and of course finishing with compensation on. Looking at the simulation, next operation, we have turning operation. Geometry, we are using Mach 1. For our geometry, we start at the beginning of this chamfer right up to the end. Tool, we are using our same roughing tool of angle 60 degree. Technology, we are using front, and we are using a roughing pass with no finishing. Strategy, non-descending. Looking at the simulation, next operation, we have groove operation. Geometry, we are still working with Mach 1. Our groove begins from this point right up to this point. For our groove tool, we are using an external groove tool of width 0.02 and a 0.02. Go for the green check. Technology, a roughing pass and a finishing pass with compensation on. Looking at the simulation, operation done. So we have 1 groove, 2 groove and 3 groove. So right now we are going to machine the other remaining grooves. For the remaining grooves, geometry, we got this groove and this other groove. So 1 groove is left. Tool, we are still using our same external groove tool. Technology, we got a roughing pass and a finishing pass with compensation on. Looking at the simulation, looking at the last groove, edit groove, geometry, we have this groove beginning from here right up to here. Tool, our same tool. Looking at the simulation, we got some rest material over here, so we have to do finishing. Looking at our finishing pass, geometry, we are working with Mach 1. Our geometry begins from this chamfer right up to the end. Tool, we are using our external cutting tool of angle 35 degree. Technology, we are using finish pass, making sure that our step down should be very low with compensation on. Strategy, we are working with non-descending. Looking at the simulation, Looking at our thread operation, geometry Mark 1. Our thread begins from this point up to this point, or simply this face. Tool, we are using an external threading tool. Looking at the tool parameter, for our external thread, as per our drawing, we are using half 13. Remember that half is the measured diameter and 13 is the tape per inch. Making sure that you are working with triangle, as thread type, select UN and find for half/13. This is half times 13. Go for the green check. Technology, as thread standard, select UN and equally select half times 13 and then go for the green check. Thread finish should be activated, making sure that you are using a step down of 0.001. Looking at the simulation, at this timing point, all our operations on the main spindle has been performed. So we have to make a path transfer from the main spindle to the back spindle in order to perform the operations on the back spindle. For this, we have to use the MCO. So the MCO has already been done in the previous tutorial. So proceeding to the operations on the back spindle, looking at the first operation at the back spindle, we have facing operation. Geometry, we are working with Mark 2. For our geometry, we have this surface. Tool, we are using our roughing tool or external tool of angle 60 degrees, making sure that this direction should be selected. Technology, we are working with back and not front. Equally, we are using a roughing pass and a finishing pass with compensation on. Looking at the simulation, for our next operation, we have this chamfer at this point. Looking at the chamfer operation, geometry, we are working with Mark 2. This face is our geometry. Tool, we are still using our same finishing pass tool. Technology, front, finish only, of low step down and compensation on. Strategy, non-descending. Looking at the simulation, if you just click on this hole, you observe that the hole diameter is 0.313 as per our drawing. Looking at the drilling operation, geometry, we have Mark 2. Our geometry is always at the center, so no need to select geometry. Tool, we are using a normal drill tool. Looking at the drill parameter, we have a drill tool of diameter 0.31 inch with length of 4. Go for the green check. Technology, our start of drill begins on the surface and our drill end at this dot point. We are using full diameter and equally we are using a drilling peg cycle. Looking at the peg data, we have a step down of 0.0025 and equally our retreat distance 0 and full recharge activated. Go for the green check. Looking at the simulation, operation done. We have this rest material due to the fact that there is a chamfer at this edge. In order to make chamfer operation, you either use drilling operation or again you could use internal turning operation. However, we will be working with drilling. Looking at the drilling cycle for chamfer, edit operation, coordinate system, Mark II tool, we are using a spark drill. Looking at the two parameters, we got a spark drill of diameter 0.5 inch. Go for the green check. Technology for the drilling start. Our drilling start is this surface. The drilling end is this surface, so 0.0. Diameter value should be activated and you just insert the chamfer value. In our case, the chamfer value is 0.45. And again, the drilling cycle should be drilling and not peg. Looking at the simulation, for the internal thread, we got measure diameter as 3/8 and our tape per inch as 16. Remember that the thread depth is 0.35. Looking at the thread operation, firstly, I'm going to change its name as thread operation. Coordinate system, we are working with Mark II tool. We are using a tab tool. Looking at the tab tool parameter, since we are working with inch system, pitch, our pitch is 1 divided by 16. Thread diameter 3/8. Go for the green check. Two direction, we are using this direction. Technology, drill start should be this surface. The drill end should be 0.35 and making sure that you are working with tapping. Looking at the simulation, solid verify. We want to synchronize the main spindle and the back spindle. Go for channel synchronization, save and exit. Looking at the full simulation, solid verify. With this, we are done with VMS Project 13. If you have any question regarding this project, do well to contact us by Facebook or by email, or even leaving a comment in the commenting box. Keep liking the video, keep sharing, keep commenting. Thanks a lot guys. See you guys in the next tutorial.